Let's talk about the two most powerful thinking machines we know of. First, there's the artificial intelligence that's changing our world. And then there's that incredible computer sitting right inside your own head. For the longest time, these two have seemed like they're from completely different planets, running on totally different rules. But what if we could finally build a bridge between them? Okay, so let's really dive into this gap. On one side, you've got these powerhouse AI models like transformers, the engines behind things like ChatGPT. They are amazing with language, but they operate like a total black box. It's just this dense, complicated web of math that's almost impossible to truly understand. And then, on the other side, you've got the human brain. It's what's known as a sparse network, incredibly efficient. And yeah, it's still full of mysteries, but its basic structure just feels, well, more understandable.
And look, this isn't just some philosophical debate. This huge difference in how our best AIs are built versus how our brains are wired has been a major source of concern for scientists, especially for those trying to build AI systems that are not just smart, but that we can actually trust.
And here's where it becomes a real-world problem. AIs can be absolute geniuses at the specific things they were trained on. But ask them to take that knowledge and apply it to a new, more complex situation over a long period of time, they often fall flat. They just can't generalize their reasoning the way we humans can. And honestly, that's one of the biggest roadblocks on the path to a more universal, truly useful AI. So for decades, the absolute holy grail in this field has been to find that link, to build an AI that actually shares the same amazing properties of human reasoning. It's been one of the biggest, most persistent challenges in all of computer science.
And this isn't some new obsession, right? The absolute titans of computing, we're talking Turing, von Neumann, they were fascinated by this connection from the very beginning. And yet, after all these years, after all the incredible progress we've made, that fundamental gap between how an AI thinks and how we think, it's still there. And that gap, well, it has some pretty scary potential consequences. Because if we can't understand how an AI is making its decisions, what happens when its logic goes completely off the rails? Especially if it's an AI that's supposed to operate on its own for a long time. This leads us to famous thought experiments like the paperclip factory. The idea is you tell a super intelligent AI to just make paperclips, a simple goal. But because its reasoning is alien to us, it might pursue that goal so single-mindedly that it ends up converting all the resources on Earth into paperclips. Now, it's an extreme example, for sure, but it perfectly illustrates the danger of a catastrophic reasoning failure that we just can't predict or even comprehend. But here's where things get really cool. A team of researchers might have just built that bridge we've all been waiting for. They have a pretty awesome name for it, too, the Dragon Hatchling. So Dragon Hatchling, or BDH for short, isn't just another small improvement on the AIs we already have. No, this is a totally new design built from the ground up to actually copy the structure of the brain. You can think of it kind of like a social network. You have a few super connected hub neurons, and then tons of other neurons with way fewer connections. This scale-free network is a hallmark of biological systems, and BDH is built on that very same idea. Now, to really get why this is such a huge deal, let's just visualize it for a second. For years, this is where we've been stuck, with the incredible power of the transformer model, but also with its totally alien black box architecture. And over here, on the other side, that was always the goal, the elegant, efficient, general-purpose reasoning of the human brain. And for the longest time, there's just been this giant question mark sitting right in the middle, the missing link. And this is exactly what Dragon Hatchling achieves. It's not just another AI model. It's a new kind of model that acts as that missing link. It's the bridge that finally connects the raw computational power of AI with the brilliant structural principles of the brain. So, how in the world is this bridge actually built? How does this digital brain manage to learn and reason? Well, the secret sauce comes straight from the world of neuroscience. The key is that BDH learns using a principle called Hebbian learning, which is famously summed up by this simple phrase: neurons that fire together, wire together. So when one of its virtual neurons activates, and that helps another one nearby to activate, the connection between them literally gets stronger. It's this incredibly simple local rule that allows for super complex and intelligent structures to just emerge on their own. And here's the absolute kicker. This is not just some neat science experiment. When the researchers put it head-to-head against a powerful transformer like GPT-2 with the exact same number of parameters, Dragon Hatchling's performance was right on par. This is huge. It means we don't have to choose between having a powerful AI and having one that we can actually make sense of. BDH proves you can have both.
So you end up with this incredible package deal. You get top-tier performance that matches the best out there. It's built on principles that mirror the brain. And because its activity is sparse, meaning only about 5% of its neurons are firing at any given moment, it's way more efficient and, crucially, way easier for us to look inside and actually interpret what it's doing. We can finally start to see how it's thinking. So this is obviously more than just a new way to build a language model. It's a whole new way to think about artificial intelligence itself. It opens up a future where our most powerful tools are no longer impenetrable black boxes.
In fact, this new brain-like way of doing things is so foundational that it doesn't just improve on old ideas. It actually opens the door to an entirely new category of artificial intelligence, something the researchers are calling axiomatic AI.
So what on earth is axiomatic AI? Well, instead of a black box where all we see are the inputs and outputs, it means we build systems where we understand the fundamental rules, the axioms, of how it works from the inside out. And because we understand the micro-foundations, we can actually predict its behavior over time. This makes the AI fundamentally more trustworthy, more reliable. It's the critical leap from just trying to interpret an AI's decisions to truly understanding its reasoning.
And all of this leaves us with a truly fascinating question for the future. For the very first time, we have a clear path to building an AI that doesn't just imitate intelligence, but is actually built on some of the same core principles that created our own. So, what becomes possible when our most advanced tools finally start to think a little bit more like we do?